Hello. I just wanted to do a quick tutorial for you architects out there in showing of how I use Grasshopper to optimize the workflow of taking in these kind of site survey files that you usually get either from a company or client or the municipality and converting them into a 3D model. And for that I will be using Rhino, Grasshopper, and then maybe we'll run around on it in Unreal Engine. So that's the plan. So this DWG file is actually what we've got from one of our clients, and I've just dragged it into Rhino to check what's up, right? And you can see that it has plenty of layers. It's two-dimensional. And if I were to kind of look closely, I can see that there's a lot of data in here. So the hatches, for instance, mark out different entities on the site, such as the greenery or the riverbed, or not entities, areas, I should say. Also, we have a high voltage line going through the site right here, and so on, yada yada, right? These kind of things are unimportant to us because for the three-dimensional construction of the site, the only thing that we need are these height points, right? These marked out height points. So the first step is to make sure that the height points are actually either a single point or a circular curve, right? And text, right? So you need two separate entities for every height measurement. In this case, if I select them, I can see that it actually says one block instance. So these are blocked. And if I were to do block manager, type in block manager, I can see that there's a bunch of block definitions here. By the way, this file, the DWG file, as well as the Grasshopper script and everything that we do in this channel are available for Patreon supporters, right? So if you want to follow along with this and have exactly the same file for some reason that I have, consider supporting the channel and you will get them. With that being said, I mean, you can still follow along with your own file. So yeah, enough of that. So we have a bunch of block definitions, and that is non bueno because we need these entities to be text and a dot or a circle, any enclosed curve. So I will just type in cell block instance, select all of the block instances that you have, and just type in explode. So we're exploding out of them, right? We're removing the block portion of the block instance, right? Just to be safe, I will type in select block instances again, cell block instance, to just make sure that no objects are left behind, no blocks are left behind. With that done, I will just type in purge, P-U-R-G-E, purge, and I will make sure that we purge everything, right? So if you look at the right-hand side, as I hit OK, by the way, for Rhino 7 users, the purge tick marks are in the command line, right? So once I hit OK, you can see with the layers that all of the layers that are empty will just be removed, just like that, right? And also, if I would type in block manager, there are no blocks left, right? So now if I zoom in to any of these height points, I can see there's one text and one circle corresponding to the text, right? And this is where things start getting a little bit muddy and a little bit tricky, because we also have text here, and we have like a hatch here, and we have like curves and border lines and dashed curves and just random text. We need to start removing things, right? I think working backwards is a good idea in this case. So just selecting the text, going to the properties, object properties, and seeing in which layer was the text placed. Layer 0. Okay. Then selecting the little circle next to the text and seeing that it's also placed on layer 0. Okay, so that's the only layer that we actually need for the height information. So I will go into my layers tab. I will double click on the layer 0, right? Or we can actually do it this way. Let's select all of the layers and hide all of the layers except layer 0, right? That's, I think, better. With that done, now we have a layer in which all of our height points are located. But the problem is that there's still, still quite a few additional points out there, or not points, texts that don't really belong there, right? And in some cases, let's go to the top view so that it's easier to see. In some cases, even if I were to check the, what's the word? 1 second, give me a second. Even if the text seems that it's okay, it does not have a point on its own. So this is like an after measurement, a secondary thing that we will also need to remove, right? So there's a lot of stuff that we'll need to do with Grasshopper. With that being said, what we still can do in Rhino is remove all of these unnecessary points. So I'll just type in cell PT, cell points, and hit delete, right? Okay. From here on out, we will be using Grasshopper. And just so that it's easier, let's type in package manager, because we will be using one plugin with Grasshopper as well. And that plugin is called Human. If you have Human plugin, great. If you don't, type in package manager. And here, search Human. This one right here. Click on install, right? Then hit OK. And it will ask you to restart Rhino for it to actually work, right? So I will do exactly that. 1 second. I've actually decided to use Rhino 7 this time around instead of Rhino 8. Doesn't really matter. It works exactly the same on both softwares. So I will use Rhino 7 from here on out. And this is exactly the same file that we've cleaned up to a certain extent. There's like an icon of a, oops, don't do that, but there's an icon of a tree and so on that we'll need to, fix up. All right, so now from here on out, let's just type in Grasshopper, open up Grasshopper, and here I have already, of course, I have the script, right? I have to make sure that it works before I record the video. But basically, I'll just be using the script as my notebook so that we can, if we get stuck, we can kind of check off what the hell is it that I've done. So the first thing is referencing in the text and the curves into Grasshopper. And that is actually trickier than you might think, right? Because, for instance, if I were to go here to primitives and I were to find text, right? A text node. Let's do my focals. You don't need that one. Don't worry about it. If I just have the text node, I right click on it. And here for set text, I can only write. I cannot click on the text in my viewport. And that's an issue, right? So we can't reference the text this way. We could use GUID, I believe, and reference the text that way, but it gets muddy and a little bit tricky. So this is where the first useful thing about Human comes in. Under our Human plugin that was installed, right? Under reference, the first icon right here that says dynamic geometry pipeline, that's the one that we're going to use. And the dynamic geometry pipeline basically references every type of geometry or every geometry of a specific type from a specific layer, right? So here I have layer name and here I have geometry type, right? So if I were to create a panel, and the shortcut to create a panel is / enter, double click on the panel, and I were to type 0, and don't hit enter, just click somewhere outside of the panel. If you hit 0, if you hit enter, it makes another line, and you don't want that. So layer name 0, right? If I just connect it like that, Now this dynamic geometry pipeline reads from layer 0. And I believe it doesn't not give us anything because we didn't give it a type, a filter for what's the type of geometry that we want. So I will just write / again, create a panel, double click, or let me show you a faster way, / text, enter. And thus you create a panel with text inside, already written inside of it. And I connect that to type. Now I can see that the output is a bunch of text objects. Great. That's exactly what we want, right? So we're basically referencing in all of these guys right here, right? But unfortunately, we're also referencing in, let me find the naughty boy. Someone that's naughty. Oh, I can't. Why? Hello? Is this already? Ah, there it is. There we go. You know, stuff like this. We don't want this, right? This is bad. So we need to remove this, right? And the way or 0.1. What the hell is 0.1? So to remove this, we need to check. We need to do a bunch of checks. So the first thing that we do is for this text, we need to separate it into components. Today is a bad day to talk, I guess. So under creation, is it under creation? No, it's not. Oh my God, no, please. Well, I need to write it. No, it is here. Text object info. There we go. We use text object info. We connect text objects to text object info. I will zoom out, and here you will see that it gives us the location or location plane, right? The base plane for the location, right? So we also give information of the text is rotated for some reason. You can see that some of the text is empty. Don't worry about it. We will be removing that. Then we get the size of the text, right? So some text is bigger, some text is smaller. That's great. We get the alignment of the text. Is it centered? Is it left side, right side? And vertical alignment, you know, top, middle, bottom. We don't care about the alignment. The first thing that we will check is, okay, from the text that we have, and actually we should probably graft this so that all of the text entities arrive as separate data branches. That's just going to make things much cleaner. Let me just check if I grafted it as well, right? Graft, like that. You right click on the output G and you choose graft to graft things. Right, so the first thing is making sure that, or eliminating all of the text that is not size 2, if I remember. So I'll select this text right here, go to properties, size, height 2. Okay, so any text that is not height 2 is not going to be the height point measurement text. So we just get rid of it, right? So I will say for the size, right? I'll ask a question of equality /2. And it gives me, you know, a bunch of true or false statements. So this one is going to be true. Which one would be false? We saw like this might be false, or maybe it's also true. Either way, it's a good filter to remove all of the text that is too large or too small, right? So equality 2, we get the answer, and that is the first filter that we use. The second filter that we use is going to be how many digits are there, right? Or how many characters are we using? Because you notice that this is always going to have 5 characters, you know, 2 numbers, dot, 2 numbers, you know, meters, dot, centimeters, right? Above sea level. And like anything that we check will have 2 numbers. Of course, if you go beyond the threshold of, let's say, 100 meters, so suddenly it changes into two numbers, like two different, instead of 5 characters, you might have either 5 or 6. The script would need to be a little bit longer, but it's still basically the same process, right? So I'm going to look at the actual text that we have, and I'll break it into characters. Let's go to vector. No, not vector. Where was it? Math set text characters. There we go. Like that. It's right here. Wait, how do I show you? Pop, like that. Okay. So those characters, we just measure list length. And if I were to show you with a panel, we get an answer of, 5 characters for one text entity, 1 character for the other, 2 characters for the other. And you can see that, I mean, there's a bunch of 5s, of course, a bunch of these guys, but also there's a bunch of trash that is like 1 or 2 or 3, right? So we will be removing that. So I will ask the question, is this list equal to 5? 5. Boop. Just like that. And I believe I did some additional cleaning of this. So just give me a second. I will just take a quick look. Nope. That was that. Easy peasy. Okay. So here we check if I'll group this up and I'll just name it. I'll clean it up for you. So we check is text made of 5 characters? Answer is yes or no. And here is text size 2. Right? Answer yes or no. So for us to select the text, both of these statements, both of these checks need to give us a true answer true, yes, right? And a way of how we make it is through what's called the logic gate. And maybe I should show you what a logic gate is. Give me a second. Pop. Logic gate. Images. You have OR, NOR, AND, NAND, XOR, XNOR, buffer, NOT. Right? Those are the logic gates. And in our case, we need the AND logic gate. So if either both answers need to be true for the logic gate to give you the answer true, right? If either one of these is false, then the logic gate will give you the answer false, right? And it's not going to be kept, right? So a text that is 6 or 8 digits long but has the correct size will still not be kept because one of these was not true. So I will use AND, gate AND, and I'll just connect the equality to A, equality to B, and here the answer is going to be the that logic gate that I was talking about. I hope I did a okay job explaining it. I think I did. Anyway, so with that done, I can actually start kind of showing you. Let me show you. So let me hide all of the text. Let's get rid of the or not get rid of but let's hide the planes because they're a little bit in the way. And let's just take, wait, I need to clean this up a little bit, like that. This seems fine. And let's just cull from this text, all of the text that is referenced, let's cull pattern. So we remove, from this text, we remove all of the true, all of the false hits with gate, like that, right? So the answer, or what we get, is like 316 entities, but most of them are empty, right? So I'm going to check with, give me a second, let's think. Text tag 3D, text tag 3D. That should be a-okay if we do it that way, I guess, because we can take those entities, right, that we got, and we can again use the human plugin, reference, text object info, right? So we do exactly the same thing as what we're doing right here, but this time for a culled version of this, like that. And then we will be showing in this location this text. Bam. And let's hide everything so that it's cleaner, right? So now if I were to go around and check all of the text here, there would be no, absolutely no objects or no like weird letters or anything like that. It's all kind of nice now. Well, kinda, right? There's still objects here that shouldn't be here. So let me try and find one. 0.100, right? It has size 2, right? Oops. It has size 2, and also it has 5 characters. The problem with that is that even though it has 5 characters, clearly it's not a height measurement, right? Here as well, right? It's not a height measurement, so we need to remove those. And the way I remove them is really straightforward. You can see here. I just take the text that we have, right? And I convert it into a number. And you'll notice that when I convert the text into a number, it gives me, you know, a bunch of failed statements, and that's because some of it is actually text and not number. That's fine. The ones that it can convert to numbers, it did, right? So we convert it to number. We ask, are the numbers larger? Let's do like some sort of filtering. So what would be the lowest altitude here that we have? I see 61, I see 69, nice. I meant 68, not 61. Okay, so I'll just do a safe bet of, we definitely won't have anything smaller than 50, right? So here we get answers of, for all of these numbers will give us true, because they are larger than 50, except for that 0.0 or 0.1, right? That's going to give us a false. One thing that I want to clean up here is, you can see that while I do get true, I get a lot of nulls, and nulls are, they come in from here, where I either have an empty branch or I have actual text in the branch, right? So I will just use replace nulls, and I'll replace the nulls with 0. 0 in Grasshopper, as well as in most of the programming, is false, is no, right? So we either get true, or if it's a null, we just disregard it as false as well. Okay, with that done, now we need to add in this check as well to the family, right? So I'll write another AND gate, right? So also, actually we can just do it in a clean way. If you zoom into the original AND gate, you can just click the plus sign right here and add even more checks, right, to it. So this is our check number 3, and it's called, is the number actually close enough to our altitude to be considered an altitude measurement, or is it some random number, right? So, is the number big enough, right? That's the check. Okay, so now I guess, well, I connected it really quickly, but let's disconnect it. Boop. Right here. right? 0.1, 0.1, 0.2, and as I connect it, plop, they're gone. Filtered out, unnecessary, trash, got away. Right. I think I have one more. Yes, I do. And one more is these tilted numbers. So all of the original measurements were done, well, marked out horizontally, and I'm not sure about these tilted measurements. It might be or upside down measurements. It might be additional information, additional points that were marked out, but since I'm on the fence of it and I don't want the data to be dirty, I will be removing them. And just for the sake of the video, I will be showing you how to do that, right? So it's nice. So that is where the planes come in, right? If I were to show you here, we have the planes for everything, right? So I can go to vectors, plane, and I can use align planes like that to take the plane to align, master plane. Well, let's just see what I did. Wait, no, I did a different one. I'm sorry. Back up, delete. I just write align plane. There we go. This one. Perform minimal rotation to align a plane with a guide vector. Let me just double check if it's not a part of the of any plugin. No, it doesn't seem like it is. Okay, we're good. Align plane. So we take our text planes right here, and we align them along the x-axis. So the x-axis is the alignment vector, right? So I just write unit x. Unit x is world x-axis. So I'm basically asking if you were to rotate the plane so that your x-axis matches up with the world x-axis, how much would you need to rotate, right? And here it gives me the answer, right? And that answer I can ask, is it equal to 0? Because if it's equal to 0, I know for a fact that the text is horizontal, right? And that's the text that we want. We don't want tilted text. If it's anything other than 0, that means the text is off, like rotated weird, and we will be removing it. And I believe we here, actually, maybe we don't need to do it. Let me just double check. Yep, it gives us planes for literally everything. So that's great. We can just use this without any replaced nulls for it. I'll right click here, right click this group, and I'll name it is text horizontal, right? Is text horizontal. For the gate and I will add one more input, and I'll just simply connect. Let's make it bigger. There we go. I'll connect my equality to gate D input, right, like so. Okay. Hide that. And now if I were to check, all of the text is horizontal. There's no letters, no nothing, and it's only altitudes. Perfect. Okay. Step 2. The curves. Let me type in show. Showing too many things. Let's hide, select everything, or actually let's just make this active. Bear with me. Okay. There we go. So these guys right here are now our main focus, right? What I want from these, first of all, I want to get them in. Second of all, I want the center point. And then I want to move the center point along this value upwards. That's the plan. Okay, let's do it. So for that, I will be using exactly the same principle of dynamic geometry pipeline. The layer is still the same layer, 0//0. The type is going to be //CRV, curve, CRV. I think. Geometry? Yeah, reference a bunch of curves. Okay. Then I will ask, well, we can just ask for area. It's going to complain and give us a red sign, and be all angry at us because some of the curves are open and don't produce a point. We don't care about those curves. All we care about are these circles right here, right? Those are the things that we care about. So as long as we get the centroids, we're fine. You can see that it also, if I hover my mouse over this, let me zoom in, or actually let me just panel cleaner this way. It does give me points. Where it can't give me points, it gives me null. Null, no bueno, not good. We need to remove it. It's too dirty, it's too bad. So I will just say clean tree. Clean tree. Connect it like that. Slash slash. Look at it. Look at it. It's clean, it's nice, it's lovely. We have clean points, only these points. Perfect. Well, some of them are duplicate. Let me find an instance where some of the points get duplicated. For instance, here, we have a circle here, we have a circle here. This circle, the center point of this circle is here. The center point of this circle is here. We have 2 points. 2 points, not good. We need to somehow eliminate those 2 points. So what we will do is we will do remove duplicate points. Remove duplicate points, like that. Bam. And the threshold will be, we can be brave. Here we're working in meters, so, and it's a pretty large landscape. So let's just say any, like 2 points that are closer to each other than 10 centimeters are going to be removed, right? Already can see some things that I will address quite quickly, but for now, / 0.1, 10 centimeters, that's the threshold. Anything closer than that gets just connected into 1 point. All right. 239, 239, that's not 39, 293 points are left. And here we have 289 text pieces, right? Pretty good, pretty close. There's like 4 points that are too many. And I think, you know, this might have something to do with it. There's always going to be anomalies. And for those anomalies, I would just suggest just do that. I'm just selecting them and deleting them. Who cares, right? So I just delete them. I will just go around really quickly. The hell is that? Don't care. Just checking if there are any like cluster of points that I don't want to see. No, it seems fine. Okay, so that was the only instance where it was kind of actually manual work was required. Okay, so we removed duplicate points, and I believe this should be okay. This is now a clean list of points, but now this list of points, and let's just yoink this whole thing and drag it closer to our text object info. This list of points has no idea where these planes, or it has no idea what's the closest text to it, right? So for instance, this point has no idea that it's 72.42, right? Because there's no connection, right? It's two separate entities. We need to draw the connection. To do that, first of all, I will push all of these outputs, all of these text objects. We don't need them to be in separate data branches. I will push them into one list, and that's easy. Right click, flatten. There's just now one list, a bunch of text, very dumb list. Here we have one list, a bunch of points, also very dumb list. I will then take that list of points and I will separate those into separate branches, because I will want to take every single point and I will want to measure the distance from that point to every single text object and find the closest one, right? So I'll right click on the remove duplicate points output, graft it, bam, now they're in the different branches, and I will measure distance, I think, yes, from here to the location plane, right? I get 82,943 distances. Of course, it multiplies, right? Every point checks with every text block, right? So we have 800 or 287 points checking, each of them checking 289 text entities, right? A lot of checks. With that, we will sort list, we will sort the distances, and together with the distances that we get, we will sort the text itself, right? So we will take the text output and we will sort that as a key, right? So as an additional key. And then what we want to do is we want to take the output, the sorted output, not the K output, but the A output, and we want to use list item to fetch the lowest value, right? So, and the lowest value is the lowest distance, right? So it's not from here to here, it's not this distance, it's this distance, right? So we get the text with the lowest distance, and that is after sorting is at the start of the list, and we extract it here, right? And I can now, can I flatten it? Yes, I should. No, I don't need to. No, never mind, we don't flatten it. But it is here, and I can show you, right? Boop. For these points, this guy right here, this point in this location will need to be lifted up by 72.73 meters because that's the closest text that was to that point. This is the best I can do in terms of explaining it. Anything beyond that would require me to start drawing diagrams, and you don't want that. Anyway, we will use move tool. I will be moving the points, these, every single point. I will be moving them in Z direction, unit Z, with the values, like that. Time to look at it in 3D. Bam. Here's our landscape. Well, future landscape. All right. So now, after doing this, we get the moved points, and let's delete that. Don't need that. Hide that. Yes. Clean, clean, clean. Now we have a bunch of moved points. Now they are, every single point is still in its own little branch and they don't see each other. We don't want that, so I will right click on the G output and I'll choose flatten. After flattening it, now we can construct a mesh from these. And for landscape meshes, Delaunay mesh is used, right? So use that, yoink. And we get ourselves a nice little mesh. And let me guess. Remember when I said that there's a riverbed? I assume that's the riverbed, right? I wonder why this one is high up. 72.24. Give me a second. Which one is it? 71.10, 71. No, never mind. 70. Yeah, okay, so it goes 70.9. Right, so this is a high point. Anyway, doesn't matter. That's the data that we have. That's the data that we cleaned up and the geometry that we have extracted and have created. So with that done, basically we're finished. You have yourselves a mesh, a geometry, but I want to push it a little bit further because a mesh is, if I were to insert this and drag it over here, take a look at it. So, I mean, it's fine. That's the shape that we get, and you can build a mesh, a model on top of it. But let me show you a further cleanup. So I will be building up a Delaunay mesh from this, but what I will be additionally doing is quad remeshing it. using quad remesh on it. And I will be using custom settings. Come on. Quad remesh settings. There we go. With target count set to be, let's go for 5,000 polygons, something like that. 5,000 should be nice. Bam. A pretty nice grid. Let's hide the Delone image so that you can see better. You can see, it's kind of nice. Then for, this is adaptive size. You want 100% of it to be adaptive so that when the curvature is higher, it makes the polygons smaller, right? Then adaptive count, this is a toggle, and we use toggle true. So if it needs more polygons, it will use more polygons. If it doesn't, it will not, right? Then hard edges, seam edges, symmetry, guide curves. We're good, right? So we have ourselves a quad mesh. Then from it, we will construct a NURBS, sub-D from mesh. Really? Mesh sub-D from mesh. There's the command. I'll just connect the mesh in there. And we will have creases, corners, and interpolate. Yeah, all of this is default settings. We don't touch it. So we get ourselves, and I think this was the last one. Yeah, that's the last bit. We get ourselves a smooth version, right? Because the Delone mesh is, while it's nice and it's basically not necessarily accurate, but that's actually where the points were. The triangulation might not be correct, right? Because the Earth doesn't work that way. Earth is usually smooth, right? So this is, in my opinion, a little bit more realistic representation of what you're dealing with, not these jagged edges. Right, so then I bake this out, hide that, just like that. Then I dupe border, or rather, this is still sub-D. So we convert sub-D into NURBS. To NURBS command in Rhino, delete input objects. Yes, sub-D options, we don't change those. We keep them default. Give it a second. It's gonna think for a bit. Bam. We get ourselves a NURBS polysurface. That is actually packed quite well. You probably are seeing something like this, surface isocurves. Something like this. I just hide the surface isocurves. I don't need to see them right now, so I disable them, disable the preview of them under display settings. And this is what I get, right? So that's actually a pretty nice kind of clean patched surface. 1, 2, 3, 4, 5, 6, 7, 8. 8 patches, that's pretty good. Let's make it into a solid. Dupe border, duplicate border. Holding down the Alt key, drag down or copy down the border, scale it to 0 to flatten it. Select, or actually let's move it up a little bit. Yoink. Select the curves, loft. That was lock, not loft. God damn it. Loft. There we go. Delete. Join it up and cap it to create a surface underneath. And now we have a closed mesh, right? Or closed polysurface. Then I can just use some sort of a box or anything like that. Let's just make, I don't know, something like that. Sink it in. Something like that. Maybe. I'm starting to design things, but it is what it is. Then I will just lift this up or extrude this up, and we can do Boolean difference with this box right here, and Boolean union with this box right here. So we're making this kind of a terrace looking thing, right? And then we can do something like that, maybe. Oh, could it be? Yeah, sure. Shell thickness 0.5 meters, boop, boop, like that. There we go. So this should be enough for us to kind of export it and, oh, actually, there we go. This should be enough for, you messed that one up. It should be enough for us to export it and investigate the, you know, how that does it look in as we are running around it. So I guess I'll finish this up by quickly importing it into Unreal and actually, you know, being able to run around this landscape and understand it a little bit more from a human perspective. So give me a second on that. That's not part of the tutorial, so I'm not gonna be showing it. Here it is. Here's our landscape in our Unreal Engine project. Clearly an older Unreal Engine project that I've used for another video. If I press F, the structure opens up. There's a video on the on the channel, so just check it out if you're interested in moving architecture. But with that being said, I'm able to run on this landscape. I'm able to investigate, you know, the hills and how nooks and crannies of this space. And the reason why I'm showing you all of this portion of the video is because I want to kind of mumble a little bit about the necessity for understanding scale at early stages of the design process. It's as we were in this Grasshopper world, we weren't really thinking about how big is this landscape that I'm working on. As I was carving out the, you know, the platform or this creating this pavilion, well, I could have added in the measurements, of course, but just from like the quick sketching drive that I had, I didn't think that it's going to be this big, right? Or rather that the whole landscape is this big. And I didn't see how actually hilly this landscape will get, right? What's the changes in height that this landscape has. And the changes are quite drastic, right? So I feel like that's something that video game engines or use case for video game engines is not covered enough, right? In early design, architectural design processes, investigating your formwork, investigating the scale and understanding the scale, either through VR or through third-person character, you know, intervention, not interaction with the landscape, as what I'm doing right now. So I would just like you to think about it as well, of what is the best way for you to feel the landscape without considering that you, for instance, are unable to visit the actual site, right? And I believe that this is a pretty good alternative, right? Learning how to just slap it into Unreal Engine or whatever, and just being able to walk around and understand how high those hills actually are. Yeah, that's definitely a benefit, right? So I'll leave you with this. I'll see you in the next one. Bye.